The next thing now is going to be to locate the centers for where I'm going to have the two bolts in the front. I'll have two in the front and one in the one behind. It'll probably be located further back, but that gives the ability to slide this out. And once again, we'll take another look at that slide really quick. So I did a real quick rough grind on this piece to get it flat. I ended up having to put 2 pieces of paper towel behind it, so when I turned the magnet on, it didn't blow out as bad, and I was able to get a nice clean finish. And then also ground the sides, and I've left the top just mill scale. I'll use a solution to remove the mill scale. And then I've also welded the 2 side pieces on, reground the base, and then ground the sides on the surface grinder to have about a 4/1000 interference fit between the slide and the base. It's not a machine tool, but it is a machine tool. I just wanted to have a nice interference fit so this can be pulled out of the way if I need to change wheels, and slide it back in, clamp it back down, and carry on. So with these 2 located about like that, I should be able to get nice slides without any kind of rubbing whatsoever, and the screws will be able to clamp down on the front, keep this from moving. So we need to lay out where those holes are going to be, and then get it over to the drill press, drill the holes, and start the weldment. And poke some holes in them, added the threads. It's a 5/16 18, and 2 in this one, and 1 in this one. We're going to start setting this up for the fit up for where they're going to be welded into place. I have these 2 .093 3/32 inch welding rods or filler wire that I'm going to use to add a little bit of space from this gap section back here. And this one's going to be going about here, and then I'm just going to use the length of these bolts to space the others out. We'll get the welder set up, bring you back, show tacking, and then welding these in place. So I have completed the weld on this side and this side. This side looks a lot better. I've got 3 areas, 1, 2, and 3 of porosity. I'm still learning, so this is all I needed to do to hold these in place. If I need to cut them back off, I can come and do that easily by cutting through these welds. I'm at 120 amps. I'm going to go ahead and weld the other one in place. So I'm really pleased with how this turned out. I've got a nice slide, and if I bring the screws down, it locks it in place, except for one thing that I want to do is I want to see if I can prevent the screws from marring the top surface. So what I'm going to do is I'm going to take some silicon bronze wire and TIG on the top of one of these screws as a test to see how well it sticks before I modify the screw lengths. They're going to be close to flush when they lock down. So let me get set up, and I'll show you me learning how to do the silicon bronze on the end of these stainless screws. I was thinking that I could just hold them just like this to do the work, and I'm also interested in how much it's going to distort the threads. We can always arrange for that once we start to turn these down to final length. I just want to see how it sticks, so let's get the top of this roughed off with a file. I think that's enough right there. So I have the welder set at 30 amps. We've cleaned up the tip of this nut or bolt. I've wiped down a piece of the silicon bronze wire, just a small little section. We'll give this a shot and take a look at what it takes. I think 30 amps is a good place to start. I've never really done this before. So it's pulled up some trash on the end there. We'll let that cool down and take a look at it. I think it's cooled down enough. Yeah. So what we have is a very nice piece of silicone on the end of this screw here, silicon bronze. We'll clean that off. And then we'll try to fit a screw on the top of it. So it looks like we can do this without distorting the threads. Let's see how that looks. There we go. And I think what's going to end up happening is that should keep from marring the surface. Yeah. Nice piece of bronze. So we'll get those screws turned down to the right length and shaped, and then weld the silicon bronze on the top. So I turned the screws offline and got this little undercut dish in the front of them so that they can accept that silicon bronze. And we're going to put those, we're going to go ahead and weld this up really quick. Have a little bit of a problem here with this. Not sure if I need to check the amps or... Yeah, I'm going to have to turn it up a little bit. Drop it way too far down. There we go. Let's finish capping this one off. nice. That's what I'm after right there. My helmet's flashing on and off. I don't understand that. Alright, that one's got a nice build up on the tip. And for the last one. That went a lot better. Let these cool off, get them cleaned up. Alright, so I took the parts that I brazed Tig brazed the silicone bronze onto the end of there, and put them in the lathe. I turned a small angle here, and then just faced them off, and then came back, just nipped it with the file really quick. You screw in really well, and like this one, I didn't get 100% coverage on, but the face did turn out the way that I needed it to. Of course, the last one, same thing. Nice and clean with that softer material, so that when these are tightened down, they're going to hold the material. Cannot move that. Loosen it up. Pull it out a little bit. You can see the little nibs here. This is just a little bit of brass that's come off, compared to a divot that would be made by the actual screw. So I am very, very pleased with this. It'll allow me to pull it forward, lock it down, move it into position, lock it down, and not have to worry about this thing ever moving again. Let's take a look at one after that. So on the end there, it's just a little bit pushed down, but exactly what I was looking for. Thanks for watching. We'll continue on this project. Like and subscribe.